Hello guys, sorry for the delay. We'll start now itself. I guess you have checked the content I have provided in the group. So we'll just go through the same for a while. Is it visible? I guess, yeah, it's visible. Okay. So just one sec. All right. So today's topic is about data visualization, and it doesn't, it has a bit of the elements from data storytelling in it. So we won't be just discussing about syntaxes, but I'll give you a brief about which, what would be the different types of data that we are supposed to encounter during a project or during anything, during like a project or exploration or things like that, and how to use different tools for visualization to make or fetch insights out of it. So first, there's nothing to explain about matplotlib or seaborn, I guess. So matplotlib is the fundamental library, or like matplotlib is the most used library for data, like for data visualization in Python. And there are although so the catch with using matplotlib is that it provides us or it enables us to work with all the low level nitty gritties of data visualization in data science. So it's more of a like you can customize everything. And on top of it, many other libraries has been built. For example, you can say, for example, Seaborn is there. So Seaborn is completely built on top of Matplotlib. Now, what Seaborn does is it enables us to use fancier plots compared to that of Matplotlib, compared to its counterparts in Matplotlib. However, if we need further customization, Seaborn usually prevents us to do that directly, but we can use the Matplotlib wrapper, or we can use both object-oriented or a functional approach in Matplotlib to customize. So let's visit a bit of theory. So in the previous session, in bucket one also, I guess I have mentioned what is data visualization, and I have shared a peer present. I have shared a rough notation also, I guess. If I didn't, just raise your hand. I'll be sharing the same with you. So what is data visualization? So there could be multiple. There aren't exactly a proper definition for it, but for me, what I use is confessing or getting insight from a data without actually seeing the data or without actually diving deep into the data. So data is mostly a conglomerate of different numerical values, which could be either integers or floats or something. Now, in data visualization, what it does is it helps us to understand the nature of the data, it helps us to understand different aspects of the data by using visual cues or visual elements. So in the previous session, I've already mentioned about why do we need data visualization, or how, or which time shall we use, or when shall we use data visualization. But I'll give you a brief overview again. So focus on these points. And I've also shared the link of this. Still, I'll do it again. Just hold on. I'll share the same to the group. So you can use this, and you can even like tweak it or fork it. It's up to you. No issues. So why is it important? So we have here, I just mentioned about five different points. Firstly is enhanced comprehension. So it aligns it directly, as you can see, it directly aligns with the definition which I have just provided. Then also it helps us with pattern recognition, then effective communication. Now, for that point, in the previous session, I explained that in most of the cases, the end users or the end consumers of this are business stakeholders which are not familiar with technical details or which are from a non-tech background. So now for the senior management and everything, so what they don't want to know how did you process the data. They are not concerned about what tools or what language have you used, but they want a clear outcome or like what to take out of all this work. So it helps us with effective communication. Now, after you have done with informing the nature of the data, or after you're done with your analysis, which could be descriptive, which could be predictive, prescriptive, which could be historical analysis, whatever. So after you inform them with the decision, you inform them with the output, and it could be it could be quantifiable, or it could be qualitative, anything. It could be in terms of numbers, it could be in terms of KPIs, or it could be a detailed report. After that, also exploratory analysis, we can change the ordering here. It could be the second or third point. So it's more of a like exploring different aspects, different possibilities, and settle for some hypothesis or propose some hypothesis and study if they align, or if we should reject or accept them. So for a simple example, here you can see that you have a data. You have a textual data. Just one second. So for a simple example, this is not for you, but your students to wish. So you can see that we have a data here. So now these are just random cluster of numbers. So now if so there are only there are only five features here. So it's easy to comprehend probably. And there are only four different observations, two, three, four. Now, just still it looks very dull, very latent. Now, if we convert this to this, now you can clearly see the proportional differences and everything. So for so it helps us to like for this one, you need like to understand this to find pattern and everything. You will be taking some time. You will be taking a couple of minutes to comprehend this. Now for this one, for the visual, in the visual, as humans are primarily uh, visual learners, so or any mammals probably. So it is easier for you to process that in Q4 the budget is much more higher, and for Q2 the budget is the lowest. So it's more of a data visualization turns data into stories. Just one second, guys. Okay, sorry for the interruption, guys. So it's more of a so the key takeaway is data visualizations turns data into stories that everybody can understand. So again, let's comprehend, let's ponder. Is it all about using fancy charts, or is it all about creating like working with different languages or different libraries? Not exactly, because even if you use a fancy chart, even if you use a fancy library, or even if you are working with a top-notch technology, that actually doesn't matter, because like it could be that you have a like very fancy visualization, you have a very uh, optimized code and everything, but the data doesn't make any sense at all. So it's more about like it's not just about syntax or visuals, but more about delivering something that people will understand, and they will bring something out of it. They'll make a decision. Uh, they'll understand. They'll be aware of something. It's more about that. So in general, like from a very general perspective, we can divide data into four types. That could be categorical, numerical, time series, and geospatial. So as you know, categories could be anything. Categories could be colors, type of fruit, type of a species, type of a particular brand, maybe the level of seniority of a person. So now we can also divide them. We can also add more types of data, like it could be ordinal, like it could be numerical but without order. So you are already familiar with the same. I guess those who have studied or have a decent introduction to statistics. Now it could be numerical, temperature, sales, or customer uh, churn, like percentage of customer churn and everything. Then it could be stock prices for time series. It could be say historical data of it could be historical data of say temperature. That also, like if you are concerned about the change in atmosphere, change in pattern, or studying the change in pattern in the meteorological studies or atmospherical studies, then instead of numerical data, we'll be considering the same. We'll be considering the same as our time series data, not just a numerical value. Then you have geospatial data, which we can use for different say depends like which could we could be using on depending on their contextual reference. Now these are the primary chart like fundamental charts that we usually use in uh, daily life or in daily life as a data scientist or an analyst. So I guess you are most like quite familiar with this. So still I'll be showing them. Consider this as for like visual pillars. So yeah, just I forgot to mention about this. So for the psychological aspect, as I mentioned, that humans are in general inherently visual learners. So our brain process charts faster. Our brain process visual elements faster than text, than numerals, than other like statistical values, and we can identify the patterns very clearly. So see for an example here for a bar chart, we can clearly understand, right? We like the category C is the highest and the category B is the lowest. So now if we have like here, can you just check here on the left side? So we are actually calculating, we are actually, so is the number visible by the way? So it is 1,000. So we are actually working with 1,000 different instances here. So if I go with something called like if I go with just one second. So if I go with something for which like we have a lot of observations and everything, so it would be hard for us to actually comprehend. It would be hard for us to comprehend textual data. So for the same reason, we'll be preferring charts. For the pie chart also, you can clearly see that the category B, sorry for the color composition, I used it from a reference. So B is much more, category A is the dominating one for the pie chart. For the histogram also, you can see that in between. So for the histogram, you can see that like near 80, we have the mean, or we have the largest number of occurrences. For the scatter plot also, we can see that the blue plots are bounded by red. So overall, it helps us to actually work with our data better. Okay. So as am I audible, guys? My device was lagging a bit. Could somebody just raise their hand or like drop a text? Am I audible?
Yes, sir.
Okay.
Audible.
All right, all right. So this is the help. This is the key aspect of data visualization. Now the key takeaway is choosing the right chart depending on the right context. Now obviously you won't be choosing pie chart to for a category where we have say 20 or 30 different, like for a data where we have 30 or 20 or 30 or a lot of different categories. You will be going with a column chart or a bar chart, because what happens is that, see, for this one, for this example, I just, so if you have a pie chart and you have different categories, a lot of categories, then the catch is like for this one also, like currently you have, just one sec. So, yeah, go on, certainly. Hello, am I audible? Miles? Okay, all right. So, see, in this pie chart, the catch is we have just one, two, three, and four categories. Now, if we have like seven or eight or nine or maybe 100 different categories, then what would be the problem? The problem is that it would be just like instead of proportions, we'll be just working like it will be say the more we increase the number of categories, at the end it would be just a single line, a strand of string in a circle. So that won't make any sense at all. So that's why we need to fix which. Again, we can we use scattered plot for a time series? No, that won't work, right? So it depends. It completely depends on the context. So you can, by the way, you can use this material to for your class, and I have added different annotations. I have also like this for all these I try to cite them and everything I try to mention. So do not share the note. You can share the notebook after the class, but do not share the notebook during the class, but you can make content out of it. So now let's learn a bit about the history. So today it's more about theory. So how did it start? Like how did it start? All this visualization, this fancy stuff. Like currently we are working with Tableau, Power BI, and different, like too many advanced stuff. But the origin actually not like actually histograms and similar patterns of data visual like charts for counting data for summarizing data like that has been observed in the cave like in the images drawn by the cavemen first. So that for that like we are going back to million years. That would be maybe like I don't exactly remember the time, but so they used to use like strands and uh, marks and points for recording their stock, their livestock, their grains and everything. So and also it has been used for to and also another reason was to pass information down the line to the next generation. So there have been like we have observed, or you can find on the internet, there are different diagrams, there are different pictorial diagrams or rough paintings of different creature, and like even the like previous ancestors, they have mentioned with line with annotation that which part, like how to defeat those, how to hunt them, how to maybe farm different creatures and all, and how much what would be their expected lifetime and everything. So the what was the purpose? The purpose was simply to pass the information to the next generation. That's it. So in modern world, the first pioneer that we consider is William Playfair, and then our I guess everybody knows about Florence Nightingale. So these two are considered the pioneers of modern data visualization. They what they used to do, they actually they use different diagrams, different charts for and to support their case studies, supports to support their data. Now modern applications and everything, I don't need to explain, I guess everybody is familiar with the same. So we'll see some of the charts. So this was the this free, you can Google, or later on you can check the resources. I have also included a blog post, I guess. Yeah, you can actually check these and like learn more about this fellow. So this is more of a for your own knowledge, your own interest. So this was the trade fair, like this was a time series analysis between import and export of crops, and I don't exactly remember the entire context for between England and Denmark and Norway. Also, this is the price of straws, price of bread between 1770 and 1824. So these people were the early pioneers of it. And this is for this chart is very popular actually. The army in the east, the frontier in the east, I guess, the official name of it. So what happened is that Florence Nightingale, I'll give a brief about her. So also you can also just understand one thing. Currently, what I am using is a form of storytelling. I'm trying to analyze, I'm trying to build some motivation for you so that you can relate different concepts, you can relate different charts with reality, with history and stuff. So tomorrow we'll be taking a bit of we'll be conducting a sorry, not tomorrow. Uh, so it on Wednesday we'll be taking a session on data storytelling, and I'll be explaining how to actually convey or present your data in during an interview, during a business meeting, or in your class. So let me give you a context of this chart, the left one. So Florence Nightingale is was a nurse. Say like in a summary, you can read more about her from Wikipedia or from article. So she was serving in the battlefront, and what she observed is that the army in the east, like for a particular, don't exactly recall, it was probably cholera. So the army in the east suffers more in malaria probably in a particular fever, and but she couldn't prove. So that's why what she did, she actually created a pie chart, an exploding pie chart, and mapped the number of occurrences of patients from east and from west, and also she built different she drawn different diagrams to check which part has more land mass and more water bodies and everything. So after that, she came up with with this chart to actually prove her point. So after this, you can just go through this. These are more of a fillers. And also tomorrow on Wednesday will be like it would be a like a theoretical session regarding delivery. But today also it was about delivery. So on Wednesday, we'll be talking about Jon Snow and how actually data visualize, not just data visualization, but data visualization and data storytelling actually saved the entire Europe from cholera and black fever and plague. So actually, like usually in our data visualization lecture, I used to start by saying like there is, I just explain a bit. So in data storytelling, there could be different approaches by different people. So what I use is a hero villain approach. So first, what you need to do, just once again. So first, you need to propose an idea. Then you need to go for a conflict. Then you need to go for a resolution. We'll be talking about this in more detail in the next session. So yeah, in a summary, like say for an example, okay, Indian economy is growing. So that could be point one. Point two could be a conflict, which could be like something that exactly a complement of the first point. So first one is India's economy is actually growing. Conflict, not in terms, but our GDP per capita or our income per capita per citizen is very low than other. Like we are very behind 150 countries, I guess, or something. I don't. I'm very bad at remembering statistics. So that is the conflict. So are we actually, if our GDPs, our gross GDP is very high, like the rate is very high, but our like our point number two, our GDP per capita is very low. So are we actually, or is our economy actually increasing, actually growing, or are we actually developing? Now you have to come with a resolution. So with which point shall we go? Shall we go with one or shall we go with two? Or we can provide a different solution when we can come with a conclusion. So this is more of a this is kind of developed from a philosophical concept, which maybe like which I managed to map with. So this is more of a like if somebody is familiar with Hegel. So this is from the Hegelian triad. So this is more of a you have a thesis or a statement, and you have an antithesis or antithesis. So they both contradict each other. They both clash with each other. By this clash, we get elevated to the higher truth, the actual truth, which is known as the synthesis. So, like this is more of a like philosophy related to Hegelian, post Hegelian philosophy or Friedrich Engel's philosophy and everything. So you can explore it. Like this is not a philosophy class. So this approach is very beneficial for you in a class because you can actually use it for storytelling. For an example, you actually did it in your classroom but without even realizing. So this you can consider the like you have like all of you have studied the induction method up to some depth, I hope. So this is more of a this part, like if we get to the higher truth or if we get to the solution from the antithesis, if this like the thesis gets false becomes false and the antithesis becomes true, and we by this we resort to the higher truth, then that is known as the proof by contradiction. I guess everybody who has studied K-12 mathematics, like they have studied mathematics in their 12th, are familiar with this. So you can use these approaches during during your lecture, during storytelling, during delivering your data, or maybe when you switch, when you go to some other company, maybe like make advancement in your career. Always like your data, your resume is also a fancy piece of where you should use data visualization, because what is your resume? It's a brochure of you. You are trying to tell your story, you are trying to deliver, you are trying to talk about your journey, your quantifiable outputs, you are trying to put your entire life struggle, your entire life's journey in a piece of paper. So for that also you can actually follow these approaches. So okay, anyway, we can conclude by this, and see you in the next session. So yeah, from for tomorrow, for on Wednesday, it would be about data storytelling, and then we can resume with chapter 2 or chapter 3 and so on. Chapter 2 and chapter 3 is very small, so probably will be, and from 2 to 7 or 8, we'll be concluding that in the next session. Now this for TOM, this is very small, but in your class you can actually take 1 or 2 chapters, maybe 2 or 3 or 4 in a same session. You can go slower. In TOM, we'll be going much more faster than you are expected to do in the class. Anyway, we can conclude for today. If you have any question or anything, you can ask. You can stay in the meet if you have something to discuss about, or we can conclude, or we can close the meeting. If anybody has any question or anything, just raise your hand. Okay, guys. So I hope I feel we are on the same page. So okay.